Okay, ladies and gentlemen, you are welcome. So in this video, we are going to look at the probability with work examples. So what is probability? Introduction. Probability measures the likelihood of an event occurring. So a probability is a statistical term that used to measure the likelihood of an event occurring. And this probability, it has a range of, or it has a ranges from 0 to 1. So whenever we said the probability of something is 0, it means that it is impossible. And when we said probability of an event is 1, it means that it is certain for the event occur. Like for example, I can ask, what is the probability of a man with 2 heads? What is the probability of Bashir with 2 heads? What is the probability of Samuel with 2 heads? You know that generally humans have only 1 head. So therefore, the probability of Bashir having 2 heads is 0 because it is impossible. And when you say certain, it means that the event is certain to occur. So that is why it is 1. So probability has a range between 0 to 1. So understanding probability helps in decision making, especially under uncertainty. Like for example, you want to go and write your jam, you want to go and write post UTME. So the probability of you passing the jam or post UTME is likelihood that you will pass or you might not pass. So that is what you call probability. So you can calculate your probability of passing your examination. How do you do that? Maybe you can get a past question paper, maybe with 50 questions. So you can calculate how many of the questions you were able to answer correctly from the past question paper without looking at the textbooks or material. So from there, you will be able to calculate the number of the questions you passed and then the total number of questions. And then from there, you will be able to calculate the probability of whether you pass the exam or not. So that is what we describe as probability. So probability is usually used to measure the likelihood of an event occurring. So that is why as a student, you can even measure your probability of passing your examination. How do you do that? You can get past question paper, sit down, time yourself, and look at the questions, answer them, do it for like 3 or 4 different years. If you are able to arrive at maybe 60% or 70%, it tells you that there is a probability that you may pass your examination. So use probability in making decision, especially under uncertainty. So you see the probability of impossible is 0, and this is a die. So a die is a six-sided object. So it is also uncertainty. You can for example, you can get 1 in 6 chance. So you see, you can get 16%, and then you can also have event chance. Let's say you have a die, you have a coin. So a coin has a head and a tail. So if you flip a coin, so there is probability of you getting a head or a tail. So probability of getting a head is 50%. And also the probability of getting a tail is also a 50%. Then the likely also, let's say you have an object where there are 4 red ball and 2 blue ball. So the probability of getting red ball is 4/6, which is 66%. And then there is probability of certain, which is 100%. So that is why probability is measured between 0% to 100% or 0 to 1. 0 is impossible and 1, it means is certain the event will occur. So the basic concept of probability, so we have what we call an experiment. An experiment is a process that leads to outcomes. So whenever you carried out an experiment, so there will be an outcome, like a rolling a die. You can now roll a die to see the chances of getting one, or the chances of getting two, or the chances of getting six. So that is an experiment. You can roll a die. So the rolling of die is an experiment. So probability involve an experiment, which is a process that leads to outcome. Like for example, a this is roll a six-sided die. So these are the number of the all possible outcomes. We have 1, 2, 3, 4, 5, 6. So it has one side, it has two side, it has three side, it has four side, five and six side. So like rolling a die is a probability. So we call it an experiment. So like for example, an outcome is a possible result of an experiment. So when you roll a die, it means you are going to get an outcome. So the outcome you get is a possible result of an experiment, such as getting a 3. So now what is a probability of getting a 3? So you have to roll a die first. So what is the probability of getting a 3? So the number of possible outcomes. So we have also a sample space. What is a sample space? A sample space include all the possible outcomes. All the possible outcomes. So the possible outcomes of a die, because it is six-sided die and it has the following side 1, 2, 3, 4, 5, 6. So that is why the sample space is the total number of all the possible outcomes. And the outcome is after you roll once, what did you get? That is the outcome. And then the sample space, let's say now you roll the die. And after you roll a die, you were able to get 3. So to calculate the probability, it is now going to be outcome all over sample space. That is what you obtain divided by the total possible outcomes. That is the sample space. So to do that, you are now going to say 3 divided by, because here we have 6 numbers. So it means that the sample space at this point is equal to 6. And then the outcomes after rolling the die, you were able to get 3. So that means that, and how many do you have? Is only 1. So the probability of getting a 3 is going to be 1/6. So now, calculating sample probabilities. How do you calculate sample probabilities? The probability of an event is the number of favorable outcomes divided by the total outcomes. So the total outcomes is like the sample space, and then the favorable outcomes is what you obtain after performing the experiment. So these are the formulas that are used in calculating probability. So probability formulas are used to calculate the probabilities of event. So finding the probability of an event A happening can be calculated using the formula. So the formula now is equal to, let's say, the probability of getting A is equal to the number of times A occurs divided by the total number of possible outcomes. You have uh let's say you have the following. You have A, B, C, D, E, F. Let's say this is your sample space or total number of possible outcomes. So now, what is the probability of getting A? So what is the chances of getting A from here is equal to, so we have to count this 1, 2, 3, 4, 5, 6. So we have 6 of them. And we are now going to say 1/6, the probability of getting A. So what is the probability of not getting A? It's 1 minus probability of A. It's 1 minus probability of A. So probability of not getting A is now going to be 1 minus the probability of the A. So that is what I want you to understand. So the probability of not getting a tail is equal to 1 minus probability of a tail. The probability of not getting a 4 the probability of not getting a 4 from a die is equal to 1 minus probability of getting 4. And then we have what we call a mutually exclusive event. So this is a compound probability. Let's say you want to calculate the probability of A or B. That is mutually exclusive event. So for the mutually exclusive event, we are going to use probability of A plus the probability of B. So if you are dealing with a compound probability, so it can be a mutually exclusive event or independent event. So if it is independent event, so probability of getting A and B is going to be probability of getting A times probability of getting B. So now, for example, the probability of rolling a 4 on a fair die is 1 over 4. So maybe you roll a die. And what is the probability of getting a 4? That is 1 out of 6. So it's going to be 1 divided by 6. So now, the probabilities are always between 0 and 1 inclusive. So now let's look at an example, work example 1, rolling a die. What is the probability of rolling an even number? So remember, a die is a 6-sided object. So when you roll a die, what is the probability of getting an even number? So first, this is a sample space of rolling a die. So the sample space of rolling a die, we have 1, 2, 3, 4, 5, 6. And that is what we have here. So this is the sample space. That is the total possible outcomes. So we have this. So we are thinking about even number. What is an even number? An even number is a number that can be divided by 2 without a remainder. So it includes the 2 itself, 4, and 6. So we have 2, 3, 3. 3 is not part of it. So we have 2, 4, and 6. So these are the even number. So what is the probability of rolling an even number? So now we calculate how many even number do we have? We have 1, 2, 3. So it's now the number of probability of getting even number. We have to use the number of favorable outcomes divided by the total number of possible outcomes. So therefore, to do that, we now have 1, 2, 3. So we have 3 divided by the sample space is 6 divided by 6. So this will give us 1 over 2. So as we can see, the favorable outcomes are 2, 4, and 6. So there are 3 favorable outcomes. And then therefore the probability is 3 over 6 or 1 over 2. So then another one, we are now going to look at another example. This is example of a compound event and their probabilities. So compound event, it involves 2 or more sample event. So if you have 2 or more sample event, like flipping 2 coins. So if you are flipping 2 coins, this is an example of compound event. So compound event is when you have 2 or more sample event. And this compound event we have different event for the probability of compound. It can be independent event. So if it is independent event and you are dealing with two simple event, you are going to multiply the probability of those simple event. And if it is dependent event, you are going to multiply, sorry, you are going to get a used probability of A times probability of A divided by, sorry, B divided by A. And for mutually exclusive event is addition. For mutually inclusive event, we are going to take the probability of A plus probability of B minus probability of A times B. That will give us the mutually inclusive event. So now, if events are independent, if the events are independent, so the combined probability is the product of the individual probability. So if it is independent event, this is the one that we are going to use. That is to multiply the probability of the two simple events, two individual probabilities. For example, flipping two coins and getting heads both times. So let's say you have two coins and you roll them. So when you roll two coins together, there is a chances that you can get head to head. Maybe if you flip the coins, if you flip two coins at the same time, there is a probability that if you twist them, they can give you head to head. They can also, at the same time, when you flip them together, they can give you head to tail. And there is also probability that when you flip the coins together, they can give you tail to head or tail to tail. So now to calculate the number of heads, like here we have two heads, here we have one head, and then here we have 0 heads. So what is the probability of getting heads both times? So the number of heads is equal to 2. The number of heads are 2 because we are talking about heads. So if you flip two coins together and getting heads both times, so the number of getting heads is 2. And then the number of possible outcomes, if you take the outcomes, all the outcomes are 4. So we have 4. So 4 now is equal to, is the same thing as 1 divided by 2. This one is not correct here. So the probability of getting head both times. So when you flip the coins together, so what is the probability of getting head head? That is the meaning. Head head. So the number of heads are 2, so we divide it with the total number of possible outcomes. So another work examples when you have two coins and flips together. So what is the probability of getting exactly one head in two flips? One head. So look at it. You see, this is one head. This is one head. So it means that we have number of favorable outcomes. The number of favorable outcomes is now going to be 2. And then the sample space, that is total number of possible outcomes, is 4. So therefore now, the favorable outcomes you see of having one head, we have this one and this, so we have 2, which are 2 outcomes. And then therefore the total outcomes are head head, head tail, tail head, tail tail. So therefore we have, from here we can see that the probability is equal to 2 divided by 4, which is the same thing as 1 over 2. So now, the next thing that you are going to look at is addition rule for probabilities. So addition rule helps find the probability of either event A or event B occurring. So in addition rule, this addition rule is also divided into two. It can be either of the two mutually exclusive, that is A and B. So if it is mutually exclusive, so it is now going to be probability of getting A plus probability of getting B. So it's going to be additives, that is addition. Then for two non-mutually exclusive event, it's the same thing as probability of A plus probability of B minus probability of A times B, that is A intersection B. So now, if A and B are mutually exclusive, so the probability of A or B is equal to probability of A plus probability of B. So for example, the probability of rolling a die, so the probability of rolling an the probability of rolling a or a 2 on a die is, so the probability of getting 1 is 1 over 6. And the probability of getting 2 is also 1 over 6. So we're going to take the probability of the two and add them together, and that is what happened here, which will give us the something as 2 divided by 6, which is divided something as 1 divided by 3. So work examples for drawing a cat. What is the probability of drawing a king or a queen from a standard deck? So now, cards are divided into 4. We have pet, we have club, diamond, and heart. So if you can see, in all the classes, we have king, we have queen. So if you can see, we have from here, we have 4 king. And we have 4 queen. So the question is asking, what is the probability of drawing a king or a queen from a standard deck? So I think this is going to be simple. The total number of possible outcomes is 52. So the probability of drawing a queen, so we have for a queen, so for a king, we have 4 divided by 52. Or plus for a queen, because this is an additive, a compound. So therefore, it's going to be 4 also for the queen divided by 52. And therefore, by taking LCM, this is 52. Then we have this plus this, we have 8. It's going to be 8. So 8 divided by 52. So there are 4 kings and 4 queens. Total favorable outcomes is 8. And therefore, we have the probability as 8 divided by 52 as we have here. And at the end, we can simplify it to 2 divided by 13. So then the next thing is conditional and independent probability. So conditional probability is a probability of an event given that another event has occurred. If 2 events are independent, then the occurrence of one does not affect the other. So for example, the probability of drawing an ice after drawing a queen without replacement is different from with replacement. So in summary, and key takeaways, probability quantifies the chance of events and helps in decision making. And basic rules include the multiplication rule for independent event and addition rule for mutually exclusive event. So work examples here illustrate how to apply these rules in practical situations. So ladies and gentlemen, please don't forget to subscribe and join my YouTube community, and see you next.